Good morning, my name is Enzo Groisman. I'm a civil engineering student at the National Technological University, Paraná Regional Faculty, and I'm going to give you a presentation of the use of CRUMB rubber as an asphalt modifier to improve urban infrastructure. Well, it's a well-known fact that roadways are enormously important to every country in the world because without them, for instance, people can go from one city to another one to work, for example, or factories cannot transport their goods to the retailers. And together with an exponential growth of the urban areas and an increase in the traffic density, new road structures are needed, as well as the maintenance of the old ones because of the damage that this traffic density makes to those road structures. And that's why conventional bitumen used in the asphaltic mixture should be modified in order to increase the durability and to improve the performance related properties, which are, for example, the resistance to the fatigue cracking or rutting. The modification of the bituminous binders has been studied for years, more than anything to try to improve every physical and rheological property of the conventional bitumen. As in today's world, the rubbish accumulating everywhere is a fundamental concern, and where there is millions of tons of car tire discarded everywhere. The solution to this problem of the need of new road structures should be designed for sustainability, and that's why in recent studies it has been proved that old car tires could be crushed in order to get CRUMB rubber, which could be used as a replacement for the fine aggregate, which is the sand. And it has also been proved that the performance or the physical and rheological properties of this asphalt is improved by using CRUMB rubber as a modifier. By doing this, we will be achieving one of the challenges enlisted by the American National Academy of Engineering, which is restore and improve urban infrastructure. Well, the intention of this presentation is to study the general features of CRUMB rubber modified asphalt, and this will be done to finally present all the benefits that the use of CRUMB rubber as an asphalt modifier involves. Well, in order to achieve this, we will be first of all analyzing the raw materials and method of preparation, which involves the production of the CRUMB rubber modified asphalt. Secondly, the physical and rheological properties of CRUMB rubber modified asphalt or CRMA will be discussed. Thirdly, an analysis of the resistance to the fatigue cracking and rutting, or which are called pavement distress. Pavement distress are the damages to the superficial layer of the asphalt roads. And finally, the advantages and benefits of the use of CRUMB rubber as an asphalt modifier will be discussed. Let's begin talking about the raw materials used on the preparation of CRUMB rubber modified asphalt. We use a bitumen, a coarse aggregate, a fine aggregate, a filler, and CRUMB rubber. Let's begin talking about the bitumen. It is a material which acts as a binder for the stony aggregates and the CRUMB rubber. Where the traditional bitumens can be used in the preparation of this type of modified asphalt, and it should represent around 5% of the total dosage. Then we have the coarse aggregate, which is basically crushed rocks or crushed limestone, whose particle size goes from 4 to 8 millimeters, and it represents around the 62.5% of the dosage. Then we have a fine aggregate where different type of sands can be used, where it has a particle size distribution from 0.063% to a millimeter to 4 millimeter, and it represents 27.5% of the dosage. Then we have the filler, which is generally limestone powder or cement dust, whose particle size go from 0 to, or its particle size should be less than 0.063 millimeters, and it represents 5% of the dosage. What's the main requirement for these three aggregates? Well, we need a dense particle size distribution. What does this mean? The aggregate should be composed by equal amount of various sizes of the aggregates, which is determined by a sieve analysis or a gradation test. And finally, the CRUMB rubber, which is obtained from recycled car tires, which is an elastomer capable of deforming under different stresses and always recover to its original shape, which is why it represents a valuable opportunity to be used as a modifier. And as a requirement, it should replace at least the 15% of the fine aggregate in order to have the best effectiveness. Now, as regards to the methods of preparation, we have two different methods, a wet process and a dry process. In the wet process, what we do is we incorporate the CRUMB rubber as a very fine rubber powder to the bitumen inside a blending tank, which is a kind of shaking machine that shakes at a velocity of 2000 revolutions per minute for a shaking time of 4 hours. And after that, we add all the other aggregates. This should be done at a high temperature of around 200 degrees centigrade. Whereas in the dry process, what we do is we mix the CRUMB rubber with the aggregates, and then we add the bitumen to the mix. What happens here, the CRUMB rubber goes from being an aggregate to be a bitumen modifier. This process is called rubber digestion. What can we conclude of these two methods? That the dry process is more cost effective and easier than the wet process because we do not need any specific machine as we need in the wet process. Well, now let's talk about the physical and rheological properties of the CRUMB rubber modified asphalt. But first, let's define what a physical property and rheological property is. Well, a physical property is a property which can be measured without changing the chemical nature of the analyzed substance. For example, the viscosity, the substance point, and the penetration. Whereas a rheological property is a property which studies or analyzes the way in which materials deform under different stresses applied. For example, the ductility or the elastic recovery. So, the elastic recovery is a measure of the ability of a bitumen binder to return to its original shape when a compression load is removed. This is important because the degree of elastic recovery is used as an indicator of permanent deformation in the pavements, which what we will be talking later. So what happens when we add CRUMB rubber to the conventional bitumen? Well, elastic recovery increases as the rubber particle size decreases, and also it was proved that every modified bitumen with CRUMB rubber shows an enhancement on the elastic recovery. Now, ductility. Ductility refers to the degree to which a material can sustain plastic deformation under tensile stress before failure. And the ductility test measures the distance in centimeters that a sample of bitumen elongates before failing or breaking. So what happens by adding CRUMB rubber? Well, ductility also increases as the rubber particle size decreases, and toughness increases as rubber content increases. Well, now penetration. Penetration is a measure of softness of bitumen binder, which is expressed at the distance in tenths of a millimeter that a standard needle penetrates vertically into a specimen of the material under specified conditions of temperature, load, and duration of loading. Penetrations show lower values as rubber content increases. Why? Because by increasing the rubber content, we will have a denser and tougher asphalt, and so penetration it will be harder for the needle to penetrate into the bitumen. So that's great because we'll have a tougher and denser asphalt with an homogeneous surface, as there are less free spaces in the mixture. And finally, the viscosity and the softening point. As I mentioned, bitumen is a viscoelastic material which doesn't have a sharp defined melting point. What does this mean? That its viscosity starts to decrease as we are increasing the temperature. So viscosity is a fluid property. It's a measure of flow resistance, whereas the softening point is the exact temperature at which the bituminous binder softens beyond some arbitrary softness which is determined by an ore. Well, what happens when we add CRUMB rubber? Well, the softening point is increased and the viscosity also increases as the rubber content increases. This is great because what we are looking is we will have at environmental temperatures, we will need a much higher environmental temperatures to have an asphalt with a lower viscosity. So at environmental temperatures of, for example, 25 degrees centigrade, we'll have a strong asphalt, a strong, tough, and dense asphalt. Now, in this slide, let's talk about the damages which occur to the pavements. Well, the damages which occur are generally due to heavy traffic loads. And in this case, let's talk about the pavement distress, which are damages which occur on the top superficial asphaltic layer of an asphalt road, where rutting and fatigue cracking are the most common kind of pavement distress that can be seen on asphalt roads. Where using CRUMB rubber improves the resistance to this kind of pavement distresses. So let's begin by talking about the rutting, which is a surface depression in the wheel path, which emerges as a result of insufficient compaction of asphalt layers during contraction, improper mix design or manufacture, which is what we are studying here, the mix design of the CRUMB rubber modified asphalt, and high traffic loads. Well, how does rutting appear? It appears as we can see in the first picture, as longitudinal depressions with small elevations on the sides, which can be more easily appreciated when there's a heavy rain because it is filled with water and it can be easily seen. Well, what happens by adding CRUMB rubber to the mixture? Well, the softening point and penetration values increase, so we have a tough and denser asphalt which doesn't enable the shear deformations that give rise to roots appear. And now the fatigue cracking, which is a pavement distress which appear due to repeated loads of traffic which occur at intermediate and low temperatures. What happens here? As the number of loads increases, longitudinal crackings begin to appear, and as we continue increasing the amount of loads and traffic, they start to connect between them, forming what we can see in the second picture, which resembles the back of an alligator or a crocodile. That's why also fatigue cracking is known as alligator cracking. But different studies have shown that there's an increase, or different studies show that the increase on the ductility and the elastic recovery, which is due to the use of CRUMB rubber into the asphaltic mixture, provide us an opportunity to reduce the plastic deformation which give rise to fatigue cracking. Why? Because by having a higher elastic recovery and ductility, the asphalt can deform but always came back to its original shape when the compression load of the car tires is removed. As regards to the advantages and benefits of the use of CRUMB rubber, we have resistance to plastic deformation, because an elastically deformable conglomerate is created by adding CRUMB rubber to the asphaltic mixture. But at the same time, a highly resistant to permanent deformation is created, which doesn't allow rutting and fatigue cracking appear so frequent as it happens with conventional bitumen. Safety. There's a decrease in the number of accidents because we have a homogeneous and elastic surface, which is a consequence of having a dense gradation on the aggregates. And we have a better visibility on the rain because as we have a resistance to plastic deformation, roots doesn't appear so frequent, and that's why we have a better visibility. Sustainability. Using CRUMB rubber as an asphalt modifier is one of the best options to give old car tires a new life, because as I mentioned before, millions of tons of car tires are discarded all over the world. And also, as we have a better resistance to plastic deformation, we have less carbon dioxide emissions, because we need to lower maintenance and lower carbon dioxide emissions when producing the asphalt. Also, we have lower costs, where the reduction in the amounts of fine aggregates used because of the replacement of part of them by the CRUMB rubber, and also we have a reduction in maintenance exigencies because we have a better resistance to plastic deformation. And finally, we have better durability because there are improvements in routing and fatigue cracking resistances. And we have less pavement distress, which involves more and more maintenance exigencies. In this presentation, we presented an analysis of the use of gum rubber as an asphalt modifier. We could see that there are improvements on every physical and rheological property, an improvement on the routing and fatigue cracking resistances. Drivers are guaranteed safer roads due to the homogeneous surface. States can build roads which are more cost effective. Also, there is a reduction in the maintenance exigencies, a reduction in pollution due to the less carbon dioxide emissions. Large amounts of rubbish are recycled, which is what we are looking. And what can we conclude? That this represents a valuable opportunity to reuse those old car tires to produce CRUMB rubber, and through the dry and wet processes we can produce CRUMB rubber modified asphalt with better properties and with higher sustainability. Well, here are the references I used on this work, this presentation. And thanks for listening. Here's my email if you want to contact me, and thanks.